Okay, now, dear student, the last very important problems of divergence theorem. What is that? Verify the divergence theorem for the vector function f vector is equal to x square minus yz into I plus y square minus zx into j plus x z square minus xy into k taken over the rectangular parallelepiped. X varies from 0 to a, y varies from 0 to b, and z varies from 0 to c. Okay, let us first write down the divergence theorem. So using divergence theorem, I can write dt simply divergence theorem. What is that? A double integral over surface S f dot n cap into ds is equal to volume integral, that means triple integral over v del dot f into dv. Sir, what is dv? dv here dz into dy into dx, or dx dy dz. That it being equation number 1. Now let us find out the rectangular parallelepiped here. So it is a three-dimensional. I am going to write something here. Understand this very beautifully. Okay. Now this is a volume of the parallelepiped. I am going to write something here. This is what you have to understand very neatly. You have to understand very neatly. Okay, sir. Look at this figure. Look at this figure. I am going to explain something here. Here I am going to take this one, join this one. So join this one, and join this one. Okay, then let us take this one as a x-axis, y-axis, and z-axis. For this, this is taken as x-axis, right? And this is taken as y-axis, and this is taken as z-axis. Write down the points here. I am going to make the point here. This is O, and this vertex is A, and this vertex is B, and this vertex is C. Okay. Now let us write down the remaining vertex here. So OA, OB, OC, and take down this one as D. This is D, OD, and this is E, and this is F, and remaining this one as P. Okay, now we have to evaluate this one. Okay, along with this is, as you know, that I cap, and this is j cap, and this is k cap along xyz direction. Now we have to find out the LHS part here. Okay, now what is LHS here? So LHS is, understand this very beautifully. LHS is a surface integral over S, that means double integral over S, f dot n cap into ds, and this can be evaluated. Look at me. This can be evaluated over the six faces of what? Parallelepiped. Okay, I am going to explain what are the six phases here. Okay, I can write here S1. What is the first phase? S1 is OA. Look at me. OADB. This is the first phase. OADB. S2 I am going to write here. What is S2 here? OACE I can take. OACE or OCEC. Look here. OCEA. OCEA. S3 I am going to write S3. What is S3 here? OB. Look at me. So this is the first phase. Okay. And this is the second phase. Okay. The third phase S3 can be taken as OBFC. What is that? OBFC. This entire phase. OBFC. And S4 I am going to take. What are the six phases I have written for just reference? S4 can be taken as CEPF. What is that? CEPF, this phase. CEPF. And S5 is taken as, what is the S5 remaining thing is, S5 is BFPD. What is that? BFPD. PD, this phase, BF, PD, and S6, the last phase is nothing but what is that? ADP. What is that? ADP, this phase, ADP, this is. Okay, understand this. How to understand this? The phase S1. What is that phase? S1 is OADB, this first phase. Okay. S2 is what? OCEF, second phase. 1, 2. Third phase is OBFC. What is that? OBFC, this entire thing. Fourth phase is CE. Look here. CEPF, this phase, top phase. And S5 is BFPD. What is BFPD? Here, look here, BFPD, this phase. And S6 is this one. What is that? ADPE, this one. Okay, now, so we have the 6 phases. We have to evaluate over these 6 phases here. Now, before going to that, we have to calculate F dot n cap into ds, right? So, how can you take F dot n cap into ds? So, now, F dot n cap into ds. I can write F here. This is very, very important. X square minus yz into I plus y square minus zx into j plus x square minus z square minus xy into k. Okay, this is F dot n cap. This is F. Okay, this is F dot n cap into ds. As you know that n cap is nothing but n cap into dx dy dz into I cap plus dz dx into j plus dx into dy into k. So this is, keep this one for the reference. This is very, very needed, for that. So now we have to evaluate the LHS. What is that? So line integral, surface integral F dot n cap into ds. First let us evaluate along this one. What that? OA. Okay. Okay, evaluate the LHS. So I can run the question here. Already you know the question. Okay, now, so over phase S1, what is S1? S1 is what? OADB. So along S1, that means OADB, there is absent of Z, that means Z is equal to 0, that implies dz is equal to 0, where n cap become minus k. That is opposite to that direction, because there is absent of z, that is in reverse direction, inside back side. So therefore minus k cap. Now what happens to this F dot n cap into ds? So we have to calculate the LHS part. This is yes, F dot n cap into ds. Have a look on this. So here when z is equal to 0, remaining thing is x and y only. Therefore x is varies from 0 to a, the boundary condition. Y is varies from what? 0 to b. Now we have to fill the n cap into ds. Okay, z is equal to 0, dz is equal to 0. Here dz is 0, this vanishes. Dz here also this vanishes. So this into this is 0, this into this is 0. Now we have to take that. So here n cap is equal to minus k cap, right? N cap is equal to minus k cap. So what happens here? Instead of k, we have to take it as minus. What happens here? And z is equal to 0. Okay. Remaining is z square minus xy. Look here, along with minus z square minus xy into dx into dy. Where z is equal to 0, remaining thing is minus xy into dy into dx. So that is equal to minus into minus, that become plus. Here only I am going to write here. So x is from 0 to a. Minus into minus is plus, xy is remaining. X into integration of y is y square by 2 from 0 to b into dx is the remaining. Okay. Now apply the upper limit. No need of lower limit. So now x is equal to 0 to a. By applying the upper limit b here, b square x divided by 2. That is equal to b square by 2 into x. So now integrate here, b square by 2 into x square by 2 from where to where? 0 to a. Just apply the upper limit. So this becomes a square d square divided by 2 2s are 4. A square d square divided by 4. It is a double integral over s f dot n cap into ds. This is over the surface S1, first surface. Now let us discuss over S2, S3, S4, S5 and S6. Okay, keep this one for the reference. So now over the face S2, okay, over the face S2, over face S2. Okay, look at that over the face S2. What is S2 here? OCEF. This is what? OCEF. So here x coordinate is there, z coordinate is there, y is opposite here in this OCEA. Okay, here there is absent of what? Y. Therefore, y is equal to 0. That implies dy is equal to 0. Okay, and very importantly, y appears in the back side. Therefore, n cap is equal to what? N cap is equal to minus j here in the second space. Okay, now how to do this one? This is a very big problem and very easy also, this one. Okay, now this becomes a double integral over s f dot n cap into ds. Understand this? That is only two coordinates remaining because y is 0. Therefore, remaining is x and z. So x is varies from 0 to a. Z is varies from 0 to C. Am I right? So they are given that x is greater than or equal to 0, less than or equal to A. Y is greater than or equal to 0, less than or equal to B. And Z is greater than or equal to 0, less than or equal to C. That means x varies from 0 to A, y varies from 0 to B, and Z is varies from 0 to C. So over the face S2 there is opposite of y axis. Therefore y is equal to 0. That implies dy is equal to 0, but y appears in the back side, therefore n cap is equal to minus j. Okay, now what happens here? Okay, look at that, dy is equal to 0. Here also dy, look at that, here dy is there, here dy is there. So the k component and I component goes up. Y is equal to 0. Remaining is minus zx into j is nothing but minus j. So therefore this becomes minus of y is 0. The remaining is minus zx into what? dz into dx. That's it. dz into dx. So j is minus j, right? Minus left, y is equal to 0. So minus of minus zx into dz into dx. Where dy is 0, this becomes 0, dy is 0, this becomes 0. So this becomes, so x is equal to 0 to a. Now just minus into minus is plus. Zx is there. X into integrate z square by 2 from where to where? 0 to c. Remaining is dx. Apply the upper limit. So z is c. Therefore, c square x divided by 2. So that is equal to x over 0 to a c square x divided by 2 into dx. Now integrate with respect to x. C square by 2 into x is what? X square by 2 from where to where? 0 to a. When a is equal to x is equal to a, that becomes a square by 2. Totally what you will get? A square c square divided by 4. This is a surface integral f dot n cap into ds over the surface S2. Okay. Now here nothing but S1 is nothing but xy plane, S2 is nothing but yz plane, and S3 is nothing but zx plane. We are taken like that. Okay, over face S3 I am going to do now. So over the space S3, what happens here? That is equal to x is equal to 0. That means there is this one. So y axis is there, z axis is there. X is equal to 0. Okay, x is equal to 0. Then what happens here? Dx is equal to 0. N cap is equal to what happens here? Minus I cap. So remaining thing we have to do this one. I think you are understanding this. Okay, now have a look on this. So observe the figure only. So now this is the x is 0. Only remaining thing is y is varies from 0 to b. Z is varies from 0 to c. Okay, dx is equal to 0. Okay, here dx is there. Here dx is there. These two get cancelled. Only the part remaining is this one. Okay, where I cap is minus I. Extra minus comes out. X is equal to 0. What happens here? Minus of minus yz. Minus of minus yz. Into remaining is what? Dy into dx. Am I right? So minus into minus. So y is equal to 0 to b. Okay. minus into minus is plus, yz is there, sorry, not this one, this is dz. I can write instead of dy, that can be done as dz into dy. The inner integral is z. Okay, now minus into minus is plus, y into integration of z is what? Z square by 2 from 0 to c. So that become y is equal to 0 to b. Apply the upper limit c square. That becomes c square by 2 into y. Into dy is a remaining. Here we left this one. Okay, now integrate y with respect to y. This becomes c square by 2 into y square by 2 over 0 to b. Apply the upper limit. So this becomes b square by 2. Therefore, answer is b square c square divided by 4. This is over phase S3. Now let us discuss over phase S4. What is S4 here? S4 is what? CEPF. What is that? CEPF. That's what. Understand that. So the difficult task is here to find out the LHS. That's it. It's not a difficult, but you need a keen observation. That's it. Okay, over the phase F4, S4. Okay, over the phase S4 here, S4 is there. CEPF. CEPF again, there is a presence of x-axis, y-axis. There is a present absent of z-axis. So over S4, z is equal to 0. That implies dz is equal to 0. And n cap is k itself. That is direct to that. Okay, now we have to take that there is a presence of x and y only. Therefore, x is equal to 0 to a, y is equal to 0 to b. So now dz is equal to 0. Here also dz, here also dz. Left this. Okay, then k cap is k itself. K dot k is 1, z is 0. What is the remaining thing here? Minus xy into dx dy. We can write it as dy into dx. So k take minus outside. So x is equal to 0 to a. Integrate y. X into y nothing but y square by 2 from 0 to b. It is equal to minus x is equal to 0 to a. Here we left dx. Okay. Y is b square by 2 into x into dx. Now integrate over x. So that become what? Minus b square by 2 into integration of x is x square by 2 from 0 to a. So that become minus a square b square by 4. This is what? A double integral over s f dot n cap into ds. This is what. Okay, have a look on this. Next, let me have to find out over phase S5. Over the phase S5. How to make this one? Over the phase F5. S5, phase S5. Phase S5. What happens along S5? What is S5 here? S5 is BFPD. What is that here? BFPD. That is what you have to consider. So y is equal to b. Look at me. Very, very important. Here BFPD. This is, so y is equal to b here, right? So here y is equal to b. That implies dy is equal to 0. And this n cap is equal to j itself. This has directly affected that. So therefore there is a absent of y, there is a present of this one, yadu, x and z. So that can be taken as x is from where to where? 0 to a, and z is from 0 to c. So y is b. Okay, dy terms become 0. Here also dy, here also dy get cancelled. Remaining thing is you have to make this one in. Okay, y is b here. B square minus zx. B square minus zx into remaining is dz dx, right? Dz dx. Now integrate first with respect to z, inner integral. X is equal to 0 to a. B square with respect to z, b square z minus zx is z z square by 2 into x from 0 to c into dx. Now integrate, just apply the limit first. X is equal to 0 to a. Apply the upper limit c. That become b square c minus c square by 2 into x into dx. Now integrate this one. B square c is a constant with respect to x is b square cx minus c square by 2 into integration of x is what? X square by 2 from 0 to a. Okay. Just apply the upper limit here. What happens here? Upper limit is a. So when a is there, a c b square. A c b square minus x is a square c square divided by what? 4. This is what? A double integral over s f dot n cap into ds. So now we have to find out the last phase S6 ADPE. What is that? ADPE here from A, D and P and E, this surface. Okay. This is very important task. I hope you all understand this one. Okay, now over the face. Okay, now have a look on this. Have a look on this. Have a look on this. So the next thing is over the face S6. S6 is what? ADPE. What is that? ADPE. There is a x. That is x is equal to a. As you know that x is equal to a. That implies dx is equal to 0 and n cap is equal to I itself. Okay. So now we have to take dx is 0. Here also dx. Here also dx. Then get cancelled. Concentrate this one only. I dot I is 1 and x is a. What happens here? A square minus yz. So here y is from 0 to b because x is absent. So and z is from 0 to c. Okay, x is a square minus yz. A square minus yz into dz into dy. Let us integrate first with respect to z. So therefore y is equal to where? 0 to b. Now a square with respect to z, a square z minus yz, y into z square by 2 from where to where? 0 to c into what? Into dy remaining. Okay, let us find out. So y is equal to 0 to b. So apply the upper limit. Lower limit is 0, no need to apply that. So a square c minus y is z is c square y, that means c square by 2 into y into dy. Now let us integrate with respect to y. A square c is constant, a square c into y minus c square by 2 into y square by 2 from 0 to b. Just apply the upper limit. So y is b. So what happens here? cb a square, nothing but bc a square minus c square b square, nothing but b square c square divided by 4. This is double integral over s f dot n cap into ds. So now let us find out the LHS completely. LHS. So what is LHS here? Actually I can rub this one. I can rub this one. This is over phases. Okay, actually what is LHS? Therefore LHS, as you know that this is along S1 plus along S2 plus along S3 plus along S4 plus along S5. So that is double integral. Okay. Okay, plus along S6. We have to sum it. What is the answer here? So that is equal to, I can write a square b square by 4 along S1, a square b square by 4 plus S2, a square c square by 4. Third is b square c square by 4. And along S4 is what happens here? ABC square minus a square b square by 4 plus along S5. Along S5 is AC b square minus a square c square divided by 4 plus along S6 that is equal to a square bc at 1 minus b square c square by 4 minus b square c square by 4 minus b square. All these things get cancelled. Sorry, this one, not these things. Okay, the remaining thing you have, the remaining thing is ABC square, remaining thing, and this one and this one. From all these things we can take ABC as common. If you take ABC is common, the remaining thing is, if you take ABC common, C is left, here B is left, here C is left. Nothing but what is the remaining thing here? A plus B plus C. Let it be as equation number 1. This is the LHS part. Got my point? Now let us find out the RHS part here in a very simple way. Okay. What is RHS here? Shall I rub this one? Okay. I am going to deal the RHS part now. It's very simple. It's a very lengthy big problem. So verification of divergence theorem over a rectangular parallelepiped. Okay, dear friends, now let us understand RHS. Now RHS, what is RHS here? That is equal to triple integral over V, so del dot F into dV. Okay, now let us find out del dot F. As you know that F is nothing but I can write here. F is already we know that. That is equal to x square minus yz into I plus y square minus zx into j plus z square minus xy into k. This is the first function, second function and third function in F. So therefore, have a look on this. Del dot F is directly can be written as dou by dou x of the first function. What is the first function? X square minus yz plus dou by dou y of second function. What is the second function is y square minus zx. Y square minus zx plus dou by dou z of the third function. What is the third function? Z square minus xy. Okay, now differentiate with respect to some variable partially. A derivative of x square is 2x minus yz is 0 because it is constant, plus y square is 2y minus this becomes 0, plus z square is 2z minus that becomes 0. Simplify. After simplifying this 2x, 2y and 2z, you can take 2 as common. The remaining thing is x plus y plus z. Here this become what? 2x plus 2y plus 2z. We can take 2 as common here. Okay. 2 times of x plus y plus z. This is what? Del cross F. Now we have to take that one RHS. So RHS become, so volume integral. Okay. So volume integral, that means along with the 3 coordinates we can write. So x is from where to where? 0 to A. Y is from where to where? 0 to B. Z is from 0 to C. This become 2 into x plus y plus z into dz dv. That is into dy into dx. Now let us find out one by one. So take 2 as constant outside. X is equal to 0 to A, y is equal to 0 to B. Now integrate with respect to z first. Okay. So that is x is there, xz, y is there, yz, z is there, z square by 2. From where to where? 0 to C. Remaining is dy into dx. Okay. Now, so that is equal to 2 times x is equal to 0 to A, y is equal to 0 to B. So apply the upper limit. Z is, these are the values of z. Cx plus cy plus c square by 2 into what? Dy into dx. Let us find out this with respect to y first. What happens here? So that become 2 is already outside. That is equal to 2 times x is equal to 0 to A. Now with respect to y, we have to make this one. Cxy. Cx into y plus c, y is nothing but y square by 2 plus c square by 2 is constant. C square by 2 into y from 0 to b into remaining is dx. Apply the upper limit. 2 times of x is equal to 0 to A. What happens here? By applying the upper limit. So y is, this is the y value. Y is b. Bcx plus y is b. B square c by 2 plus y is b. Bc square by 2 into dx. Now with respect to x we have to integrate. Bc into x is what? X square by 2 plus b square c divided by 2 into x plus bc square by 2 into x from 0 to A. So that is equal to 2 times of, apply the upper limit a. What happens here? A square, look at that, a square bc by 2 plus a b square c by 2 plus a bc square divided by 2. Now if you multiply 2, all the three terms, 2 to get cancelled. Remaining thing is a square bc plus abc square plus abc square. That is that. ab square c plus abc square. From all these things you can take it as abc is common, remaining is what? A plus b plus c. That is 2. This is RHS. From 1 and 2 we can conclude that LHS is equal to RHS. Therefore, dear friends, understand divergence theorem is verified. This is all about Gauss divergence theorem. I hope you all understand well about this Gauss divergence theorem, right? So now in future, so we discuss few more problems related to this vector analysis, right? So thank you so much. Have a great day. Thank you.